Hello Gators, this is 2-1 Parallel Lines Day 1. Let's take a look at what parallel lines are. They are lines that are on the same plane and do not intersect. So in this particular picture, this line AB, and line CD are what we call parallel lines because they're on the same plane and do not meet. Skew lines, on the other hand, do not meet also, but they are not on the same plane. So line CD and line EB are what we call skew lines because they don't meet, but they're not on the same plane. Parallel planes are planes, again, that do not meet. Let's take a minute to go ahead and do this problem to make sure we understand that vocabulary. Parallel lines are lines that do not meet. So line AD, make sure you put a line symbol over it. This line right here is parallel to this line. It does not meet with line BC. And we have a parallel symbol, and it looks like this. Skew lines would be two lines that do not intersect. We can still go ahead and take line AD, but we want another line that is not in the same plane, so we can use line BF. There is no symbol for skew. We just write a comma. Those are two skew lines. Parallel planes, that would be like the top flat surface. Remember, we need three non-collinear points, so you can say A, B, C. If you want to say A, B, C, D, you can. And plane, and the bottom one. Again, all we need is three non-collinear points, but if you want to use all four, that's okay. A transversal is a line that intersects two or more coplanar lines. So this is the transversal, and here are the two other lines. These two lines, the space in between them is called the interior. Anything else is called the exterior. So we call these four angles interior angles, and we call 1, 2, 8, and 7 exterior angles. We have a special name for this exterior and this interior angle. I'm going to say angle 1 and angle 5. We call them corresponding angles because they're facing the same direction. Angle 2 and angle 6 would also be called corresponding angles because they're facing the same direction. Angle 3 and angle 7, and angle 4 and angle 8. These are all facing the same direction, and they are non-adjacent. Alternate interior angles are from the interior, and they're on opposite sides of the transversal. So angle 3 and angle 6 would be alternate interior, also angle 4 and angle 5. Alternate exterior angles would be angles in the exterior, so angle 1 and angle 8 would be alternate exterior because on their opposite sides of the transversal, they are non-adjacent. Angle 2 and angle 7 would also be alternate exterior angles. Same side interior angles, again, we're working with interior angles. Angle 3 and angle 5 would be same side interior angles. Angle 4 and angle 6 would also be same side interior angles. Take a minute to stop the screencast and see if you can give all the answers to these four types of angle pairs. And here are the answers. Let's take a look at some algebra in preparation for lesson 2.4. The first one is, what is slope? And slope is really the tilt of the line, how it's tilting. And we do have a formula to help us figure out that tilt of the line. So I'm going to call this x1, y1, x2, y2. So we're going to subtract the two y's, 7 take away 3, all over 9 take away 4. And so this answer is 4 over 5. So this has a slope of 4 over 5. There is another way to figure out the slope, and it's to figure out your rise, because that's what subtracting the y's is doing. It's telling you how much it's rising, and the run is telling you how much the x is changing, and that's 5. So another way to figure out the slope is to use the graph and figure out the rise over the run. In this case, the there is no rise. If you go from this point to say this point, you're actually going down and over. And when you have to go down, you have a negative slope. If you're working with this point and this point here, you are going to rise and then run. This is going to give you a positive slope. Over here, you see there is no rising, there is only a run. And if there's no rising, that's 0. And if there's running, it's, you know, a number, some kind of number. But in the end, it's 0. And over here, there is a rise. We do have some kind of rise, like say 3, but there is no run, which is 0. And anytime you divide by 0, that is undefined. So a vertical slope is undefined. I'd like you to stop the screencast and see if you can find the slopes for these 3 pictures. And here are the answers. Again, you could have found the answer by just going rise over run. This would be 2 over 3. And here's the answer right here. Over here, you're rising, but there's no run, so that's why it's undefined. Over here, you're going down 2 units, and then you're going over 4 units. So this is going to be a negative slope, which is negative 1/2. All right, let's talk about finding the equation for a line. There's 2 ways to figure out the equation of the line. One is slope-intercept form. You need to know the intercept, and you need to know your slope, and your slope again is your rise over run. If you know these 2 pieces of information, you can write the equation of the line. There's also what we call point-slope form. As long as you have a point, and it doesn't have to intersect the y-axis, and you have a slope, you will be able to write the equation of a line. Let's take a look at this example right here. I am going to write the equation of the line in 2 ways. First, I want to figure out the slope. And it looks like I'm going down 1 unit and over 4. So this is negative 1 over 4. And I do have this point, and it's point 1, 2, 3, 4, 0, 4. I do have a y-intercept, so I do know that this is 4, and I do know that my slope is negative 1/4. So I can write my answer as y is equal to negative 1/4 x plus 4. There is another way to write the answer. Again, our slope is negative 1/4, and our x coordinate is 0, and our y coordinate is 4. So we can write y take away 4 is equal to negative 1/4 x. So you don't have to write that minus 0. And you can see these 2 are really the same, because if you add 4 to both sides, it'll look like that as well. Let's do another problem. In this problem, I'm going to have a hard time using this one because I really don't know what my b is. I don't know where it's crossing. So this is where this is an advantage. First, I want to figure out my slope, and it looks like it's rise. That's 3 units over 1. So this is 3 over 1, and I can pick either point. I'm going to pick this point, 1, 2, 3, 3, 1. So I have a point. I'm going to put the 3 in for the x. I'm going to put the 1 in for the y, and my slope is 3. I'm going to clean it up, and I'm going to write the answer like this. And I'm going to leave it that way. I'm not going to write any more. I don't have to make it look like mx plus b. Let's do it one more time. And it looks like, again, this is not a very good one to use because I can't figure out what my b is. Let me figure out my slope. It looks like I'm going up 2 units. No, 3 units. 1, 2, 3. And it looks like I'm going over 1, 2, 3, 4, 5, 6. So when I reduce, that's a slope of 1/2. And I'm going to use this point. You can use either 1, 1, negative 1. I'll use that point. And everywhere I see an x, I'm going to write a 1. Everywhere I see a y1, I'm going to write negative 1. And then my slope is going to be 1/2. So I'm going to have y take away negative 1 is equal to 1/2 x minus 1. And we could clean this up still and write y plus 1 is equal to 1/2 x minus 1. And it's okay to leave your line, your equation of your line, this way. And this is the end of the screencast.